In technical interviews, you'll often be asked, why use a linked list instead of an array list? Array lists store data in a continuous block of memory. They are fast for looking up items by index. But if an array list gets full, it has to find a bigger block of memory and copy everything over. This is slow. Linked lists solve this by scattering data wherever there is free space in memory. Because the data is scattered, we can't rely on indexes anymore. Instead, we wrap our data inside an object called a node. Every node must contain two things. First, the data you actually want to store. Second, a pointer or a reference. This tells the computer exactly where the next node lives in memory. Without this pointer, the rest of your data would be lost forever. When we link these nodes together, we create the chain. The very first node is called the head. This is the most important variable. If you lose the head, you lose the entire list. The last node points to null, telling the program, "Stop here, the list is over." Many implementations also track the tail, a pointer to the final node, to make adding to the end much faster. Let's talk about time complexity. How do we find a specific number in this list? Unlike arrays, we can't jump straight to index 3. We must start at the head. We check the first node. Is this it? No. Follow the pointer. Check the second node. Follow the pointer. Check the third node. Is this it? Yes, we found it. We have to walk down the chain one by one. In big O notation, searching takes big O of n time. But here is the linked list superpower. Insertion. To add a new item to the front of an array list, you have to shift every single element over. That's big O of n time. On the other hand, to add a new item to the front of a linked list, we create a new node. Point its next reference to the current head. And then, update the head to point to the new node. Done. Big O of 1 constant time. No shifting required. How does this look in Java? We start by defining the node class. It has an integer variable for the data. And crucially, it has a variable of type node called next. This is a self-referential class. It literally holds a reference to another object of its own type. Next, we define the linked list class itself to manage the chain. It only needs to store one piece of data, the head pointer. In an interview, you'll be asked to write a while loop to traverse the list. We create a temporary pointer called current. Start it at the head and loop as long as current is not null. Inside the loop, we simply move current to the next node. This is the core algorithm of linked lists. To summarize for your interview, array lists, fast big O of 1 lookups but slow big O of n insertions. Linked lists, slow big O of n lookups but lightning fast big O of 1 insertions at the head. Master this concept and you'll crush your next technical interview. Happy coding!